say about
okay. Right. Good afternoon, everyone. Please have your camera on. I really would appreciate it. I know you guys had an exam, but I didn't do the grading yet, so it's going to be done the next few days. So hopefully by Sunday, you guys will have your grade on the exam. And I hope you did well. Okay, today we are going to, I've talked about domain prior to the test, but I did not include it on the test. So we're going to talk about the domain again today, but we're going to, of course, introduce another word, which is called the range. And then if we have time, we start section 2.3. But at the beginning, we're going to go over domain one more time because usually students have difficulties with that topic. So section 2.1, domain of a function. So, and be ready for questions. I'm going to pick up student and make them answer. All right, so suppose you have a function. It means we have a rule. You give it an input, it gives you something, an output. And as the input changes, the output changes as well. Let f of x be a function. Then the domain of f, the domain of the function f, is all the x values or all the input values for which the output makes sense. Output makes sense or exists or makes sense. Okay. Or in other words, the domain is all the x values, because sometimes x values more tangible to you. To the domain of a function f is all the x values that yield such that f of x is a number. As simple as that, is a real number. So the domain are all the x values such that f of x is a number, is well defined, or it makes sense. All right, so let's start with some simple example. So the domain are, you're going to give you this rule. Domain are all those x values such that the rule is well defined. So we're going to do lots of examples. The first one is just to make explicit the definition. So suppose I give you a function, which is, I'm just going to make it up, 0, 1, 2, 3. So these are the input values. And the output values, I'm going to assign to 0, -2, 3, 5, 6. So this means my rule does the following. It sends 0 to -2. That's really what the rule is doing. It sends 1 to 2, 2 to 5, and 3 to 6. That's what you have. So in a situation like this, what's the domain of f? It means what are the x values for which f of x is a number, or does that f of x make sense in a way? So in this scenario, what is the domain? Okay, anybody? Please have your camera on. Most of you.
Oh,
Yeah.
0, 1, 2, 3.
0, 1, 2, 3. Don't be afraid of the answer. Absolutely correct. It's just both numbers, because if I tell you what's f of 4, you tell me you don't, f of 4 doesn't exist. You didn't give me an f of 4, so it's not in the domain. Now the problem with the domain, so this is really a relatively simple scenario. The problem with the domain is when the function is given by a formula. And the domain is going to be, in those cases, all the x value or the allowable x value. That's that when you plug in into the formula, f of x is a number. And that's what we took up last time, and that's what we're going to take again. So now we're going to take a function where the rule is a formula. And our question is, what are the allowable x's that spits out a number? So example number 2, and there are going to be tons of those. Suppose I take f of x equal 1 over x minus 4. Okay, 1 over x minus 4. What is the domain? It means what are the value that I can input for x, and f of x will really yield a number. It doesn't yield nonsense. That's really the domain. So the question is, find the domain. That's really my question. Okay. Now, anybody has any recollection? What's the domain of this function? It means what are the allowable values of x that will yield an output? Okay, let us remember.
Would it be 4 and negative 4?
4 and negative 4, are those in the domain or negative? Clarify yourself a little bit.
It was just a guess.
What? It's a guess. Okay, that's what we're going to try to get out. Try not to guess. All right. If I have a function like this, it means here there is a denominator. Okay? There is something down here. And when does the denominator, if you have a fraction, okay, when the fraction doesn't make sense. Whenever you have something, whatever the something is, and the light isn't working, and you divide it by 0. Whenever you divide something by 0, this is not defined. So division by 0 is not defined. Okay. So whenever we have a rule, and this rule, I'm trying to see if I can focus better. And if this rule involves a denominator, which value of x will not yield an output? It means which value of x will create this type of scenario?
4.
4, exactly. 4 will create a problem. So it means if I input x in here, if I put 4 in here, the output is going to be 1 over 0, which is not defined. It means the value of x equal to 4 does not yield a number. So x equal 4 will not be in the domain. Is there any other value besides 4 that won't yield a number? So before we do it systematically. So if I put 1 in here, is there any issue with the output? So if I input 1, do I have any problem with 1? What's gonna f gives me? 1 over 1 minus 4 minus a third. There is no problem. The only thing that gives me problem is what makes my denominator 0. So how are we gonna find here? How are we gonna find the domain? First, we're gonna do it here. We're gonna find all the x's that makes the denominator 0. So we don't really have to guess. So what are the x that makes the denominator 0? X equal to 4. Means this will give me a problem. So the domain is going to be all the allowable value, all values of x, such that x is different from 4. Everything is allowed except 4. So it means I can put anything. If you think of the function as a machine that you give it a number, it spits out 1 over this number minus 4, this machine will accept everything except 4. When you give it 4, it cannot give you any number because it should have given you 1 over 0, which is not defined. Okay. So to be able to find the domain, whenever I have a denominator, I have to look, when can this be 0? And those values should be excluded. And so we're going to do 3 problems along the same line. Then we switch scenario. So again, suppose now I give you f of x equal x in the numerator. And in the denominator, I wrote them differently, but that's not. 2x plus 6. This is my function. So the rule is you give it in x, so that's the machine. And the machine should give you x over 2x plus 6. And the question is, what's the domain? Which value of x you cannot give to the machine? Or you, right? I give you a minute to figure it out, and then we're going to work it out algebraically, the problem.
It would be -3, right?
You will be negative. So what's the domain? Write it in a clear way.
All real numbers except for -3.
Exactly. Now, where did you get -3 from?
I just knew that if x was -3, it would make it 0 because it would be -6 plus 6.
Very well. So which equation you needed to solve? So
The bottom.
Yeah, so be very clear. What the bottom?
You just plug in the denominator, you just plug in the value of x and solve it.
Right. So we set to x plus 6 equal to 0.
Yeah.
Yes, so the algebra is, we ask ourselves, what's make this 0? You can guess it, but sometimes it's not trivial to guess it. We need to solve it. And then you solve for your x. X equal -3. Which means that if you input a -3 here, the machine basically cannot give you anything, because if you input -3, the numerator will be -3, but the denominator will be 0, which is not defined. So the allowable value are everything except -3. This is not allowable. We cannot really give it. That's the idea of a domain. So one more along the same lines. And so suppose I take f of x to be equal x plus 1 over, let us say, 5x plus 4. Okay, that's really, so I always have a numerator, I have a denominator, it means I have an issue. So what is the domain? Okay, you have like a few minutes, and then I would pick a student this time, and I would like an answer. Okay, I'm going to pick one student. If, you know, I remember that I don't know you. So even if I pick, I don't know who I picked. I forget. Matt Aquino. Are you with me?
Yes.
Okay.
So the domain would be from -∞ to -4/5 to -4/5 to infinity.
And then that's it. Let me see what you told me. Let's see if I understand. -∞ to -4/5, right?
Yes.
So why 0 is not in the domain?
I mean, no, and then the -4/5 to infinity.
Okay, so let's write it in a very easier way. You're absolutely correct.
Okay.
What's an easier way to write it?
All real numbers except for -4/5.
Right. You're absolutely correct with your notation, but I want to write in a very simple term.
Yeah, I'm sorry. I'm just used to the other one.
Oh, okay, that's your other one. All right. So what is it we solved though?
I solved the denominator equal to 0.
So the denominator equal to 0. That's really how to do it. And then 5x is -4. X equal -4/5. That's the value it should go. That's the value which is not allowed, because it will spit out a 0 in the denominator. Everything else is allowed, and that's what the domain, every allowable value. Right. Now suppose I give you f of x equal, you know, I don't have a denominator. I have like x squared plus 2x. What's the domain here? Sometimes you do harder stuff and then we forget the easy stuff. Okay, I'm gonna pick another one. Jared Bauer. Are you with me? Jared, are you with me?
Yeah, I'm with you.
Okay, What's the domain here?
Domain would be, is it, hold on,
Remember, all the allowable values, all everything that is we can allow. What do you think gonna be the domain here?
would it be all values except for 0?
Why? If I plug in 0 in here, what will it spit out?
You would get 0.
Is there any problem with that?
No.
No, exactly. So it's going to be the domain.
So it'd be all value, or it would be 0, correct?
The domain, what do you mean 0? Only 0 in the domain? You're only allowed 0 in here? Are you allowed 1? If you enter 1, would you have an output?
Yes, so it'd be all real numbers.
Right, it will be all real numbers. So you have to look at the function, you have to look at the rules and ask yourself, what are the allowable x's? There is no denominator here, so I don't have to worry about that. And I can always evaluate x squared. You give me a number, I can tell you what squaring it is. Plus 2 times this number. There is no issue with the value of x you input. So the domain is all real numbers. So we should not be caught up always by that scenario. We can have a very simple scenario. We should not be afraid of it. Right. The second problems we're going to deal with domain is the idea of when the formula involve a square root, a term under a square root. And let me remind you that, actually I can write it here, let us recall that. Okay, that square root of 0 is 0 because if you take 0 and you square it, you get a 0. Okay. And then another point that it is important, besides square root of 0, that only positive values, or the 0 value are allowed under the square root. Under the square root. Okay, so square root of 0 equals 0, look at that straight, and only positive value or the 0 value are allowed under the square root. And this is because the square root, so the square root basically is a number, so that when you square it, you get what's under the square root. So the square root of -4, why is not allowed? Should be a number such that when you square it, you get -4. But the idea that any number squared is positive. Squared is positive. Okay. So if you take any number, if you square it, you get a positive number, because suppose I take 2 square, that's positive. And if I take a negative number and I square it, the negative give me positive, that's also positive. So any number squared is positive, so this cannot occur. So this cannot occur. So that's why whenever we have a square root term, only positive value or zeros are allowed under the square root. We cannot have something negative. Now, why we bring up this topic? Because quite often you're going to have functions where the rule involves a square root. So again, the question is find the domain. I'm not changing topic. Okay. Suppose f of x is a very easy, the square root of x minus 4. Okay, so now my function, my rule involve a square root term. And now the question is, what's the domain of this function? Okay, I let you think about it a little bit, and then I take you from there. Please put your camera on. It helps me a lot. Find the domain. It means what are the allowable value of x? What is it you can plug in for x and still have a number? That's what the domain is. Okay. Anybody is ready?
Any number less than 4.
Any number less than 4. It's in the domain or not in the domain?
4 is in the domain.
4 is in the domain. Okay. I agree. All right. Anything else in the domain? Because you plug in 4, you get, okay, square root of 0, which is 0. Anything else?
I got any number greater than 4, greater than or equal to 4.
Any number greater or equal to 4. You are 100% correct if you can justify it.
The first thing it did was get it out of the square root, so I squared it. So that gave me x minus 4 is equal to 0.
Why
And
did
I
you
got-
square it? You're almost on the right track, but there is one thing that bothers me. Why did you square it? I don't need to square it.
Not square, but like get it
You're fine. You're getting the right idea, but I'm trying to nail it down to the end.
I'm just used to square.
Don't worry. Okay.
Getting it out of
the square root, under the
yeah.
square root.
Yeah.
All right. So let us see what's the domain. To get the domain here, we need all the values of x. Remember, the square root, only positive values are allowed under the square root. That's really the idea. So if I want to find the domain, only the positive value are allowed. So what we need here, that's really what I'm going to put here. What we need to find is what are the x's so that the x minus 4 is positive. Okay, so what we need to go after are the term that makes the term under the square root positive. It means we need to solve x minus 4 positive. So if x minus 4 is positive, it means x should be bigger or equal to 4. These are the values which are allowed, because anything that makes this expression negative, the square root is not defined. So the domain here will be all values of x such that x is bigger or equal to 4. Okay, so that's really domain. Those are allowed. So 5 is allowed, 6 is allowed, 3 is not. If I input 3 here, I will get 3 minus 4 is minus 1. I'll have square root of minus 1, which is not defined. So this would be my domain. So we look, what we have to solve is we take the term under the square root and we say, I want this to be positive. Which axis will make this term positive? So bunch of problems along the same line. And every time you have to tell me, what do you need to solve for? What is it you go after? So example number 2 is, I probably had given it last time. I forgot what I gave you last time. Square root of 6 minus 2x. Again, the question is, what's the domain? What are the allowable value of x? Again, I will give you a minute. You have to do it and tell me what is it you need to solve to be able to do it. So some are putting their answers on chat. I actually like that because it helps me. Value less than equal to 3. Very good. I'm having correct answers. All right. I think fine. Amber, would you like to explain your answer? Amber, you're with me, right? I'm sure you are. Oh, my mic doesn't work. Okay, Brianna. Brianna, can you explain your answer? What did you have to solve?
So what I did was I know that -2 times 3 would equal to a 6. So I know that 6 minus 6 would make it 0 and nothing else can go. Like you can't have a negative in the square root.
So what did you solve? Did you try to solve anything or you just guessed it in a way?
Well, I just guessed it and I just put the
Okay, all right.
6 and
Yeah,
then
that's fine. But let's learn a strategy to do it. So if the problem gets a bit harder, we don't have to worry. What I want is I want this term. I want to find the value that makes this term positive. You see how I did it? So my goal is that which axis make this term under the square root positive? So I try to solve for it. So how can I solve that? What do you want me to do to solve it? Please, I like answers. In mute and answers. Okay, -6 both sides. Okay, thanks, Elizabeth. So I'm gonna take -6 both sides. That's how really actually we solve it. All right, so now, then what am I supposed to do? Divide by -2. And if I'm gonna divide by -2, what am I supposed to do? All of you. We have to flip the sign. So if this is bigger, this has to be less or equal. So whenever you have an inequality and you multiply or divide by a negative number, you have to switch sign. So this is going to give me x less or equal to 3. Okay, so now what's going to be my domain? Every value of x, which is less or equal to 3, will guarantee that this term under the square root is positive. So it means all values of x such that x is less or equal to 3. This would be my domain. It means only those values are allowed for input. Nothing else is allowed. 4 is not allowed because it doesn't give me a real number. Now, if we pick up our calculator and we try to graph this function, the picture will be like this. If x is 3, so this is my x, and this is my function. If x equal to 3, my output is 6 minus 6, which is 0. There will be no output for x bigger than 4. There will be output only when x is less than 3. So on the graph, if we pick up our calculator, that's how the graph looks like. There is nothing here. There is no output here. There will be only output when x is bigger or equal to 3. And that's really the reason why. That's why you will see a graph that's going to look like that because of the way the function is defined. So I would like to do 2 more problems along the same line. 5 plus 4x. My question to you is find the domain. And again, I will give you a minute to do it. And I'll see what you guys came up with. And I want you to tell me what you need to solve. And then we will write the domain. Or what think about it. I'll start putting answer in the chat to see what you guys came up with. Okay. No answer in the chat yet, so. Okay. All right, that's better. All right, Cindy, can you talk?
Yeah.
Yeah. Okay. What is it you need to solve?
You said the equation greater than or equal to 0.
Which equation? Let's be precise.
5 plus 4x.
Yeah, this is, we call it expression. Equation, just for the language. Equation, it means you have equality between two things. That's what equation is. All right, this is just an expression. It's not, equation is equality. So you said the expression, what?
Is greater than or equal to 0.
Absolutely. Only the axis that makes this positive will be allowed. So it means what? Keep going now. Solve it for me.
You subtract 5 from both sides. And then you divide 4.
We can do that because 4 is a positive number. So we do not have to change any sign. So this means that if I take any value larger than -5/4, I plug it in here, I get a positive number. So the domain is going to be all values of x. That's that x is larger or equal to -5/4. Okay. So will -1 be in the domain? Yeah. Okay. Now, suppose I do the following. I take 1 over the square root of 5 plus 4x. How will this change the picture? Sorry, I need to mute you all. Okay. How will this change the picture?
You would only set the expression to be greater than, but not equal to 0.
Absolutely correct. Now I have two issues. I have a denominator that I will not allow it to be 0. And I have an expression under the square root that has to be positive. So this time, the only difference between it and between the first problem is that I need to solve strictly positive. It means 0, I will not allow. I will not allow my expression to be 0. And this would give me x strictly greater than -5/4. It means 5/4 will not be allowed. And then now my domain would be all x values, or all values of x, where x strictly, oh sorry guys. Okay, strictly greater than -5/4. And that would be my domain. Right? Now my last question is the following before we move to the range. So is find the domain of the following function. Okay. Suppose I give you f of x equal 1 over x times x plus 2. Okay, I didn't give you whatever square root. I don't want to. Find the domain.
Can I ask a quick question?
Of course.
So for this problem, is it going to be how the last problem was, where because it's in a fraction, it's not going to be greater than or equal to, it's going to be either just greater than or less than?
Is there a square root in this term, in this problem?
No.
So do we care about positive or negative?
No.
What do we care about?
I don't know. I'm still not doing too great on this.
I know it's always hard for the student. That's why I do it twice. What do you think is going to give me a problem here?
The two x's.
Yeah.
Or the parentheses.
Keep going.
The
Everybody, anybody can help. What value of x you put for the input is not going to give you an output. No, no. All of you are still, no, I'm not having correct answers. Keep putting your answer in the chat. Think about it. There is no square root here. That's why I give that now. There is no square root. What can cause problem in this particular function?
X can't be 0.
X
or
cannot be 0.
X can't be -2 either.
And x can be -2. These are the value that gives me problem. Because there is no square root. If there is square root, I have to worry about making the term under the square root positive. Here, I only have a denominator. So what I should worry about is the values that makes the denominator 0. So in this case, what I need to do is I'm gonna look for those values that makes the denominator 0, because that's the only issue I have here. So there is no square root. So there is no positive things to worry about. So you have to look at the function. If this is 0, it means x equals, +2. And x equal -2. So my domain would be everything but those. All values of x, such that x not 0 and x not equal to 2. Okay, so please don't just say, okay, she did positive in class, so we do positive. I do positive when this expression, when the formula involves a square root term. There is no square root term. So what really caused this is a denominator. I have to find what makes this denominator 0. That's the only thing I have to worry about. 0 and -2. These have to be excluded from the domain. So if I enter 0, I'll have 1/0. Function doesn't make sense. If I enter -2, 1/-2 times 0, the function doesn't make sense. Those are the ones that I should exclude. Okay, so you have to be careful. What is it? What's inside? What's involved in this function? All right. I wasn't planning to give this example, but I will give it to see if you guys can function with it. I'm going to put x here, x -2. Now I want you to be very careful. This will be my last problem here. Think about it. What are the x's that can give me problem? Think through that. Sorry, x +2, my apology. X +2. Keep thinking, keep thinking. X cannot be 0, right? And x cannot be less than -2. So what's the domain? Write the domain in a proper way, Matt. Okay. All values greater than or equal to -2. You have correct, Diana. So here I have two issues. I'm having some answers, some are good, some are half correct. I have two issues. I have a denominator and I have a term under the square root. So what do I need? Having denominator tells me that which value x cannot take. Which value x cannot take. That's because I have a denominator. So I cannot let x to be 0. So x cannot be 0 because a 0 in the denominator gives me a problem. Now, I have this numerator that involves a square root. So which condition the numerator imposes on me? The numerator would tell me, okay, you need the x plus 2 also to be positive or equal to 0. It means you need x to be bigger or equal to minus 2, larger or equal. So what's going to be the domain here? Every number bigger or equal to minus 2 is allowed except 0. So everything bigger than minus 2, but except 0, I cannot have it. Okay, so the question is, so the domain is going to be all values of x such that x is different from 0, because 0 makes the denominator 0. I have to get rid of it. And x is bigger or equal to minus 2 to secure that what's under the square root is a positive number. Okay? And it will never get harder for us in this class as far as the domain is concerned. It won't get harder than this particular problem. Okay, so look at it and start interacting with it. You know, if it involves square root, I have to guarantee what's under the square root is positive. If it involves a denominator only, I have to make sure that I take away all the value that makes the denominator 0. If it has both, then we think a little bit about the problem. Right. Now we're going to talk about the range. So the domain is all the x values such that f of x is a number. That's when the function is given by a formula. Now the range is the output value, because remember the function, you give it an input, the input changes, and this will give you an output, f of x. The range is going to be all those output values. So as your x changes, the output change. The range is going to be all these output values. So the range, defined it, and then we're going to work with it a little bit. The section 2.2, range of a function. Okay. First, the definition. So what's a range? So let f of x be a function. It means you have a rule. A function. Then the range of f, the range are all the output value. Are all the output value. In other words, the range are all the f of x. The range is the collection of all f of x, the output. All the f of x for x in the domain. Okay, the only examples will make you understand the idea. So again, examples. So suppose I have, this is it, my rule. And I start with a table all the time because tables are easy to interact with. That's my function, okay? And I'm taking 0 to -1, 1 to 5, 2 to 7, 3 to 8. Now what is the range? The range, so these are the input, and these are the output values. So x is signed to 0, -1, to 1, 5, to 2, 5, to 3, 8. The range are all those output values. Okay, that's really what the range is. So the range are all those output values. Means all the f of x. 7. Okay, so this is the range. It adds all the f of x, all the y values. The domain here is what? So I always write both so you will not get confused with them. The domain are all the x values. The range are the y values if you want, or the f of x. So in the domain here, let's not confuse them, are the input. That's my domain. But the range are all the f of x. Yeah. Example number 2, we're going to have a graphical example. Now the range, if a function is given by a formula, the range is hard. So the only way we're going to find the range is graphically. It means I will give you the graph or a table or like a story if you want, and then we're going to find the range. So we will not find the range for a function given by a formula unless we graph it. That's the only way we can find the range. Otherwise, it's a little bit hard. So in my example number 2 and 3 are going to be graphical in nature. So this is my function. I'm going to graph it in front of you so you guys can copy the graph. Suppose my function is like this. So this is a point, let me call it -1, 2. And this is 5, 6. And my function kind of dipped down here and there. This is my graph. What you see is it. There is nothing extra. There is nothing more in the graph. Okay, and now my question is, what is the range? The range are all the y values, all the f of x. So let us understand it. Is -1 in the range? Is -1 in the range? What does it mean?
No.
No, it means can you find an input such that the output is -1? No, so it's not in the range. Is 7 in the range? Quickly. No. So what is the range? They are all the f of x. So what's the range? Is 0 in the range?
Looks like it.
It looks like it, and you're right. So what's the range?
0 to 6.
Absolutely. The range is 0 to 6. Is 2. 2 is in the range. 6 inside the range. Or if you don't, or you can write all the values of y. So that's another way you can write it. Such that y is less or equal to 6, bigger or equal to 2. So that's another way you could have written this answer. What's the domain? So for the range, that's the range. So that's the range from here to here. That's the range. Okay, that's the picture. What's the domain? From -1 to 5. Absolutely correct. So the domain is the x values. So that's the domain. To the domain, I'll write in the different color. 2 is from -1 included and 5. It means all the x values such that x is between -1 and 5. Okay, so the range, as I said, we will only do it graphically. I'm avoiding doing it algebraically. So whenever you have the range, you graph it and you see what you get. All right, so now another example, a graphical example as well. Okay, suppose I graph my function like this. Okay, so this is my x and y axis, and my function is go like that, keeps going. So it never stops. This is a function that we will encounter. And here, it never touches the x-axis. It keeps going forever, like that. Okay. And now my question is, what is my range? What's the domain? Okay. Now I'm going to ask some student this time. I'm going to pick you arbitrarily, as you guys know, and ask about the range. I hope. Okay. All right. Hunter, are you with me? Hunter, are you with me? I guess not. Okay, Grace, are you with me?
Yes.
Okay. Can you give the range your best shot?
So negative infinity to 1?
To 1?
No, negative infinity to 0.
Okay, is 0 included, you think?
No.
Because is there any input whose output is 0?
No.
No, because my graph keeps going, never touches the x-axis. And you are absolutely correct. Okay, stay with me. What's the domain?
The domain is negative infinity to infinity.
Exactly. You give me an input, I give you the output. No question asked. So negative infinity to plus infinity or real numbers. Either way of writing will be totally acceptable. Okay?
I have a question. For the range,
Yes.
why would 0 be included?
Not included. Okay,
Okay.
let me make sure the notation. Yeah, this will bring up, make sure the notation. When we put bracket, so 0, 5, for example, it means 0 is included, 5 included. So this means everything between 0 and 5.
Okay.
When I put, not I, that's the notation. When we put parentheses here, parentheses, it means 5 not included. You see
Okay.
0 included, and we're going to do this notation, so I want you to do it. So the range is now here, because that's a parenthesis, 0 not included. Now I want 0 to be included, I put bracket.
Okay, thank you.
Okay, so this is going to give me all y values, if you want, such that y strictly negative. Okay, that's what, and it's important to know that. It's important. Bracket included, parentheses not included. All right? Thanks for the question, actually. Now we're going to take a graph, which is going to prepare us for the next section that I want to emphasize as, it's a simple idea. So I'll call this as an example number, whatever this example number. Suppose I call it 5. I'm going to graph a function in the following way. And okay, so this is my function. It goes like this. Suppose this is a 1 in here, and a -2 in here, and a 1, and a 2, and a 3. And I'm going to put here, and this point is 1, 2. And then I'm going to put something like that. Sorry, I'm going to lift it up a little bit. My apology. If this is 1, okay. So this is closed, and this. So let me make sure we understand. This is a closed circle. That's a closed circle, or a full circle if you want. Full circle is better. So full, and that's a circle which is open circle. But usually I call them closed and open. So closed circle or full circle, and this is open circle. Okay, so suppose my graph is like that. Let us see, so it's a 2 pieces basically, you know, somehow 2 pieces. So let us a little bit understand, read this graph. So suppose I tell you what is f of -2. What will be your answer quickly? 0. If this is -2, the output is 0. Suppose I give you f of 0, what should be your output quickly? What's f of 0? 1. What is f of 2? This is my 2. What is f of 2? 1. F of 3, 1. So those are simple. Now the question is, what is f of 1? In this problem right there. Okay, so we have a closed circle here and an open circle here, and 1 should align with them. If it doesn't show it aligning, it has to align. So it's this my 1 right here. Now, when you have a graph like this means that at 1, the output is all the way up to the closed circle. It's not the open circle. So in this case, if I ask you what is f of 1, f of 1 is equal to 1. So it's the closed circle that gives me the output, not the open circle. And that's very, important. We're going to start using it. So here, if I ask you what is f of 1, f of 1 is equal to 1. So it's where the closed circle is, not when the open circle is. So let us say I can, I do this to this function, you know. I'm going to do that. I'm going to open this here, something like that. This is a 4, and I'm going to close it here and go like that. So I'm going to just play a little bit with the function so I can totally explain to you the idea. In this case, what is f of 4?
0.
Exactly. F of 4 will become a 0. That's not f of 4. It's where the closed circle is about is equal to 0. All right? That's how we read closed versus open. Now, since we're dealing with domain and range, what's the range of this function? I'm not changing. So it's a weird function, but we're going to start working with that very soon, actually. So what's the range? It's really bizarre, but what's the range of this function? Means what are the output values of this function? What are the output values? Okay.
Would it be 1 and 4?
1. So remember what the range is at the output value. So let me see what you guys are giving me. 1 and 4. Where to get the 4 from? The range. Remember what the range is?
The range would be 0 and 1.
From 0 to 1? So let me ask you the following question. Is -1 in the range? It means, can you give me an input where the output is -1? Remember, the range are the y values. Is -1 in the range? Yes or no? Or write on chat, yes or no, because some of you have their screen. Yes, because this is -1. Is it in the range? It means, can you give me an input where the output is -1? Yeah, whatever this ended up being, that's in the range. Is 0 in the range? Yes or no?
Yes.
Yes. Is 1 in the range?
Yes.
Is -2 in the range?
Yes.
Is 3/2 in the range?
Yes.
Is 2 in the range?
No.
What's the range?
-infinity to 2 non-inclusive.
Right. The range is going to be from minus infinity all the way to 2, but this 2, I'm going to put parentheses to emphasize the fact that it's not in the range. So it's not from 0 to 1. The range are the output value. So it's everything all the way to 2, but 2 is not included. So the range of f, we're going to write it in the following terms. So it's minus infinity all the way to 2, or if you don't like the interval notation, all values of y such that y is strictly less than 2. Okay, everything all the way up to 2 not inclusive. So I did not change the definition of the range. The range is always the same, all the output value. So it's everything up to 2 open at 2. And what's the domain? Okay. So I want the domain. So I go back to the graph. What do you think is going to be the domain? Considering the picture I have. Means what are the input for which there is an output, giving the picture. Tristan, would you like to answer?
Would it be all values in between -2 and 4?
Why? Why you restrict yourself to -2 and 4? If I take this graph here, let us say this is -3, and this is numbered, right? So you do have a number. Is there an output for -3? This is -3. You go all the way.
Oh, yeah.
There is an output, okay? Is there an output for 5?
Yes.
So what's the
So it's,
domain?
all real numbers.
Exactly, or real numbers. Everything, yeah, all real numbers, from minus infinity to plus infinity. So all real numbers, or in interval notation, you can write minus infinity plus infinity. Either way will be absolutely acceptable. Okay, so nothing changed. The definitions is always the same. We just change a little bit the graph, the way the graph looks like. Now, this type of the graph is called the graph of a piecewise defined function. And the section that we're going to start a little bit today and work on it next time is, can I find a formula for this graph? And how do you write a formula for a graph like this? So it's a really bizarre graph. It's not a line. It's like pieces. So the question would be, how can I write a formula that would represent this type of a graph? Right? So right now I'm going to start with an example that a little bit put us on the track to find a formula for this function. So the notion of piecewise function. This is my problem. You don't have to write it, actually. It's verbatim from your book. So suppose I have the following function. I said, let f be the function that assigns. So there is an assignment to each person. So the domain are all people. The number of letters in their first name if the person is a female. And the number of letters in their last name if the person is a male. So it's a function defined in a rather weird way. I don't have a rule for every person. The rule depends on whether the person is a male or a female. So let us say, suppose I take f of Kamala Harris. According to my rule, what's f of Kamala Harris? And then I'm going to take another one. I'm going to pick one student in this class. So I'm going to pick, for example, let me see a name which is easy to write. Easy to write. Hunter, that's easy to write. Hunter Desvosky, that's hard. All right, what's f of Kamala Harris? according to my scenario. Read the function. F assigned to each person the number of letters in their first name if the person is a female, the number of letters in their last name if the person is a male. So back to you, what's F of Kamala Harris? Kamala Harris is a female. 1, 2, 3, 4, 5, 6. That's equal to 6. What's the F of Hunter Zesvalsky? 8. 1, 2, 3, 4, 5, 6, 7, 8 is equal to 8. Okay, so the rule here is basically depend on what type of input I have. Is it a male or a female? Now the idea is, how can I write this in a more symbolic way? I mean, this is whole story. How mathematically we're going to rewrite this? So this is the idea. The way we're going to rewrite this in a more compact way is as follows. I'm going to say, let P be a symbol for person. Okay. And I want to describe F of P in a symbolic way, not by writing a story. But the problem is, there is not one rule that governs any person. The rule depends on the person. So we're going to define it like this. I'm going to put big braces here. Braces. And I'm going to say that F of P is equal to the number of letters. So watch carefully how we're defining this. The number of letters in the first name. And then on the side, I say the rule is this: if, in the first name of P, if, that's how we're going to write it, if P is a female. So if I'm telling the whole story, we're going to find a way to describe this function. And it's the number of letters in the last name name of P if P is a male. So the way we're going to rewrite the story is, I cannot tell you F of P is the number of letters in P, because that's not the case. So the way we're going to rewrite this whole story is like this. The number, what's the rule? Is the number of letters in the first name if my P is a female. Is the number of letters if my P is a male. So the definition of the function is going to depend on what P is. So the way we're going to read it now, what's F of P? You look here. All right. Female, that's the rule. Male, that's the rule. So that's how we're going to rewrite this letter. This type of functions have a name, and those are called piecewise function. Piecewise functions. Where does the word piecewise come from? Because this function is defined piece by piece. Means this function, the rule depends on where my input is. So there is not one rule, there are different rules depending on my input. Okay. And that's really what we're going to be heading for next time. All right, so I will not start next section. So I will let you 5 minutes early today, because I don't want to start this section piecewise function till next time. For next time, I assigned practice problem. Please do them. As you know, that's the only way you're going to learn. So the practice problem are about domain and range. Make sure you do them, because as I said, the students have difficulties with those topics. So if you do them, you will be fine. And on Brightspace, I have a worksheet that I would like to work with you on it next time. Please print it ahead of time, which will make working with it much easier. Okay. And the online homework will be assigned on Thursday and will be due the following Thursday. Okay.
Thank you very much, ma'am.
Sure. Any questions?